This is practice 2, number 2, and we are still looking at the series circuit. So now we have a problem. It tells us that the voltage of the battery is 30 volts and connected to 3 identical light bulbs. So that means that R1 is going to equal to R2, which is going to equal to R3. And then that also means that our total resistance is equal to 3 times whatever the resistance value is for each one, since they are all equal. And it also tells us that each light bulb has a resistance of 5 ohms. So that's really good information to know, because then we can fill out our matrix here. So total voltage is going to be 30 volts, because that is what's given to us from the problem. And each light bulb has a resistance of 5 ohms. So we'll know that we have 5 ohms here. This is also 5 ohms. And this is also 5 ohms. So that means when we add this up, our total is going to be 15 ohms. And let's go ahead and solve for our current, since that's what we have right now. We have V is equal to I times R, and we have 30 volts is equal to the current, which we don't know, times the resistance of 15 ohms. Now to get the current by itself, to isolate it, we'll divide by 15 ohms. And we'll get 30 volts divided by 15 is going to give us 2 amperes, which is our current. So we can just go ahead and fill this in to our ammeter and fill it in our Ohm's law matrix here. Now to get the voltage drop, remember that this part is the voltage drop for each resistor. So let's go ahead and fill that part out in our drawing here. So all charges going into the battery will have 0 voltage, and when they come out, they'll be the total voltage of 30, because, in our case, because that's what the problem says, and that's what's given to us. So 30, 30, and 30, and now that it goes through this first resistor, we'll have to think about what that number is. Now we can look at it in 2 ways. Okay, so way number 1 is our ammeter is going to read 2 amps and 2 amps. So for resistor 1, we'll have a voltage drop is equal to I of current 1 times the resistance of 1. And we don't know what the voltage is, but we know that the current is going to be 2A, because in the series circuit, all the current is the same all throughout the circuit. So we'll know that this is 2A times the resistance of 5 ohms. So we have a voltage of 2 amps times 5 ohms, which is going to give us a voltage drop of 10 volts. Now the other way that we can do it is we can look at, so that's method number 1. Method number 2 is our total is 30 volts. And for each resistor, the voltage drop for each resistor is going to be equal. So it's just going to be 3 times whatever the voltage drop is for each resistor. So that'll be, let's see. So voltage 1 plus voltage 2 plus voltage 3 will be 3V, and when we divide that, sorry, not 30, we'll divide it by 3. We'll get that each voltage drop has a drop of 10 volts. So this will be 10 volts, 10 volts, and 10 volts. Now that will only work if it's the same amount of resistance. So if the resistors are all identical, then it'll only work if that's the case. Otherwise, it'll be different. Okay, so if this drops 10, so that means this is going to be 20, and this will be 20 until we see another resistor. So this will drop 10, which will now be 20 minus 10 is going to give us 10. And this is 10 minus 10 will give us 0, 0, and 0. So when we draw our schematic diagram, we have our battery, and we have our first resistor, we have an ammeter, and then we have another resistor, and then we have another resistor, and then we have an ammeter, and we have our full circuit. So this diagram represents what the scenario is, and now we are going to label it with our letters. Or actually, let's fill in our ammeters. So this is 2 ammeters, or sorry, 2 amps, and this is 2 amps. So we have A going in, B going out of our battery, and then before a resistor, after a resistor. Don't worry about the ammeter, it's fine. And so before a resistor, after a resistor, before a resistor, and then after a resistor. And so when we do our letters, we'll have A all the way through H. And then if you want to get fancy, we'll draw A so that you can see it goes back to A. And then we have 30 is our highest, so maybe we'll go by tens. So we'll have 10, 20, and then 30. Okay, let's go ahead and graph this. At point A, so at location A, we have 0 amps. Then at B, we have 30. At C, we still have 30. And then D, we drop 10. So now it goes to 20 after the resistor. Okay, so this is going to be resistor 1. So we see a drop in resistor 1. Now in E, there's another 20. It stays at 20, but then it drops because it goes through a resistor. And so this drop shows us the drop from resistor 2. Then at point G, it stays at 10, then the final drop to H, and then it goes back to A. And that drop will be represented by resistor 3. So you should have this all completely filled out. And if you have any questions, make sure to email me or shoot me a text.